Hello students, today we are going to solve the question paper. Here we have the question paper Mathematics 2 for ECE stream. Subject code 22MATE21, which is very helpful. We are going to solve all these questions one by one. In the part A, we see the 7 questions. All the 7 questions today in this video lecture I am going to simplify. Let me solve one by one. So all the students, please remember wait till the end of this video. Share with your friends students. Without wasting the time, we'll solve this now. Find the unit vector normal to the surface x square plus x square y plus 2xy z is equal to 4 at point 2 minus 2, 3. Let us take the function here, students. So let the function here we are going to take. The gradient vector, let us take this as f of x, y, z is normal to the surface. We consider this as gradient vector, and let us take the function f of x, y, z is equal to x square y plus 2xz, and we'll substitute in this formula. Okay, so let us take this f of x, y, z be equal to x square y plus 2 x z. We'll compute one by one partial derivatives. So we'll take dou f upon dou x is equal to differentiate x with respect to this function x y z, x square y plus 2x z. So here we can see, students, that only x is our variable, y and z are constant. Therefore here we get 2xy plus 2z, and we differentiate this f with respect to y. Therefore this is equal to only y we are going to differentiate. X and z are constant, so this will become 0. Only will remain with the x square. Differentiate f with respect to z. This term x square y will become 0. Only we have to differentiate this term. Here z, the differentiation of z is 1, so we remains with 2x. Now we have the gradient function, that is dou f x comma y comma z, or simply we take it as dou f, which is equal to dou f upon dou x I plus dou f upon dou y j plus dou f upon dou z k. So just substitute all these values, we get this as equal to 2xy plus 2z I plus x square j plus 2x k. So likewise we found out the gradient vector. Now they have given one point here, students. What is that point they have given here? At 2, 2, 3, what is the value we have to calculate in this example? So therefore we just substitute the values in this example. Just look here, it is 2 minus 2, 3. We substitute in this. So therefore we get the value at 2 minus 2, 3. We have nabla f is equal to, substitute the values here, students, one by one. So this is 2 remains as it is, x is 2, y is minus 2 plus 2, z is 3. This is with respect to I, plus x is 2 square, so this is j plus 2, x is again 2, so substitute 2 k. So therefore in simplification we get the value as, if you can put it in calculator, we use the calculator here, 2 into 2 minus 2. Please remember, whenever there is minus, use the brackets ones. Okay, plus 2 into 3. What we get here, friends? It is minus 2. Okay, so therefore this is minus 2i plus 4j plus 4k. This is what we get the values. Okay, then we'll find the unit vector. Please remember the formula for unit vector, that is v bar is equal to v bar divided by modulus of v. So that is magnitude of v. So as we see, this is the unit vector. So if you take dou f as our function, then we get here v bar is equal to dou f upon modulus of dou f. It is as good as same. So therefore, we'll simplify this notes. First, we'll find the magnitude of dou f, which is nothing but the square of the coefficient of I, coefficient of j, coefficient of k, which is nothing but minus 2 square plus 4 square plus 4 square. You substitute in the calculator, students, quickly. Look here. So this is, we take square root. As this is minus, so therefore we take minus 2 square plus 4 square plus again we have 4 square, which is equal to, yes, it is 6. So okay, let's take this as 6. Substitute in this. This is equal to 6. So therefore, we get this as 1 by 6 minus 2i plus 4j plus 4k. When you simplify this, ones, we get the unit vector, that is v bar is equal to, so 2 by 3 is minus 1 by, sorry, 2 by 6 is 1 by 3 I plus 1 by 3 j. Oh, this is 2 by 3j plus 2 by 3k. This is what we have the answer. So quickly, like this, we'll simplify the next example, students. Next example, here we have, if the vector f, they have given the vector f, and we have to find f curl f. Yes, students. Without wasting the time, we'll write the second example. Solution 2. Yes, students. So first, we take the f bar function. F bar function is x plus y plus 1i plus j minus x plus y k. This is the function given in the question paper. Yes, students, it's given x plus y plus 1i plus j minus x plus yk. Then we have to find f bar curl f bar. Okay. So one by one, we'll find, this is the scalar quantity we get. As we see, we know that f bar, f cross is a scalar quantity. Okay, so we'll simplify first one by one. We'll compute first. We try to found out what is nabla f bar. Please remember the formula I j k. Here we have, and this is, we have dou upon dou x, dou upon dou y, dou upon dou z. X with respect to I, if you take, it is x plus y plus 1. J is coefficient is 1. Similarly, k coefficient is minus x plus y. So therefore, we'll simplify this ones one by one. So this is equal to, we'll find out the determinant in this case. Let us take the determinant I will take here in the bracket, leave this row and column, cross multiply. So you will get this as dou upon dou y minus, okay, minus I will take it outside so that there will be no confusion, x plus y minus, here we have 1 into dou z, dou upon dou x 1. So this is with respect to I, we get minus j. When you consider friends, again leave this column and row, cross multiply, we get this as dou upon dou x minus x plus y. Okay, minus cross multiply dou upon dou z. Here we have x plus y plus 1. So I'm doing a little bit quickly so that we want to finish our class early. So now you can see I'm going to take k, cross multiply with this row and column, cross multiply, students, dou upon dou x 1 minus dou upon dou y x plus y plus 1. Yes, students. So now we'll simplify one by one. Look here, students, how we are going to simplify this. Here we can see when we differentiate this with respect to y, keeping x and z constant, we get this as minus 1. So I put here minus 1. This is 0. Constant is always 0. Minus j, here we have. Now differentiate this dou upon dou x minus x plus y. X is variable, take as minus 1 now. As y is constant 0 with respect to x, minus, here we have again minus. As we consider here, there is no z term in this, therefore we'll take considered 0 plus k. Again with respect to constant, it is always 0. Minus, now we can see dou upon dou y, we are going to differentiate x plus y minus 1. So therefore this is 1. So here we get the answer, that is equal to minus I plus j minus k. This is what we get the answer, students. Now we are left with only f nabla f cross. We'll simplify. We have already calculated nabla cross f bar. Now we'll just substitute this answer. Please remember this, students. F, we have taken this as x plus y plus 1 with respect to, in this case it will be I, so it will going to multiply with I and I will become 1. Therefore we get this as x plus y plus 1. Sorry, this is minus 1 plus, now again with respect to j, when you multiply j into j will be 1, and we get 1 plus with respect to k we get here minus x plus y into minus 1, and k into k will become 1. So please remember the corresponding value here. What is, we have taken this as f, we are multiplying I into I, j into j, and k into k. So that is a dot product. Now when we simplify this, friends, to get this, we get this is equal to minus x minus y minus 1 plus 1 minus x, minus into minus plus. Here also minus into minus will get plus. So x will get cancelled, y will get cancelled, 1 will get cancelled. This is equal to 0. This is how we simplify, friends. Quickly we'll go to the next example. Yes, friends, let us solve. Let us solve the third question. Determine whether the vector v1, v2, v3 are linearly independent. Yeah, let us see in this question. v1, v2, and v3 are linearly independent or linearly independent. Let us determine this, friends. Very simple solutions we have. So here this is v3. Okay. So after second question, second problem, we'll simplify the third solution. Let us take the solution third. So first, we roll out the existing independent or linearly dependent. Let us take v1, v2, v3 and we see, are they really linearly independent? Let us write down a v1 plus b v2 plus c v3 is equal to 0. Okay, this is same as checking if the matrix formed by these vectors are columns has linearly dependent columns or not. To form this, students, let us first write this all the three vectors in the form of matrix. So let us consider the matrix. Let the form of matrix be denoted by A, which is equal to 1 3 2 2 1 5 3 7 8. This is the matrix we get here, and now we will check whether the columns of A are linearly independent. Suppose if it is not linearly independent, then it is linearly independent. But if it is not linearly independent, it is dependent. We find out that if the determinant is non-zero, if it is non-zero, the columns we can see after simplification are independent. Means there may be any solution. And if the determinant is 0, the columns are dependent. So let us check the determinant first. Based on that, we find the solution in this easily. We take the matrix E now, we find the determinant. So determinant of A, det of E, which is equal to, we find the determinant 1 3 2 2 1 5 3 7 8. Please remember, students, right hand side we are going to use the calculator. When we have calculator, nothing to worry. On the calculator, students, very very important. Immediately go to the mode setup, set into the matrix. 6 is the matrix. So let us select, go to the matrix A 1, and because this is 3 cross 3 matrix, so we'll just press once again 1. So here we have the all zeros, rows and columns are zeros. We'll substitute one by one. 1 3 equal to 2 equal to 2 equal to 1 equal to 5 equal to 3 equal to 7 equal to 8. This is how what we have got the full matrix. We have substituted the matrix in this. We just go to the now AC, shift, go to 4. And we want in the terms of determinant, so I'll take this 7. Again shift 4. The values are stored in matrix A, so I'll take 3. Then press equal to. Here we can see the determinant is non-zero. Easily we can see that it is. So just mention here the determinant is not zero. Therefore, the matrix A, its determinant is non-zero. Please remember this, students. The columns are independent. When the columns are independent, friends, we can see we can mention this as determinant of A is minus A because it's determinant of minus. Therefore, we just mention this as the vectors are linearly independent. So without wasting the time, we'll move to the next question, students, immediately. Here we have the next question. Find the smallest positive root of the equation x square plus 4 sin x is equal to 0 using Newton's Raphson's method. Okay, here we'll simplify this. Question number third one. Okay, here we have. Okay, so solve this example, students, quickly. So take down the question number three. Sorry, third one. Find the smallest positive root. So let us take the function here, students, first. Let this function be equal to 0. So let us take this as f of x is equal to x square plus 4 sin x equal to, let us consider this as 0. Look it in the question paper, students. They have told us to find the smallest positive root of the equation x square plus 4 sin x is equal to 0 using Newton's Raphson. Okay, no problem. We use the Newton's Raphson's formula here, students. Please remember the formula. So formula says that xn plus 1 is equal to xn minus f of xn divided by f dash of xn, which is your Newton Raphson's formula. We also call it as NR method. Let us take the function here. We already considered the function. We differentiate this the function. Therefore, what is f dash of x? Students? F of x we know. F dash of x differentiate x. F of x with respect to x. So therefore, it is. Let us take this. Okay. So differentiation, friends. We are going to take 2x plus 4 cos x. Okay, done. Now we'll try one by one substituting the values. Start with the plot taking 0 and we find how it is going to simplify. So therefore, let us start with 0. F of 0 is equal to 0 square plus 4 sine 0, which is again 0. So now, because this is 0, so since the roots lies between this double check, we can also see that LHS is also equal to RHS. So x is equal to 0 is the root, but the question what the smallest root, positive root, we assume does include 0. Suppose you think that there exists some more smallest root from 0. We can also go to the calculator and we'll try to find out. Okay, let us try on the calculator, students. Go to mode setup, go to the table. Now we'll take out 2 for x. Okay, then this is we have plus 4. Let us take this as sine x. It is alpha x. X. This is what we have the actually the question. So now just press okay. This is sorry 2x. It is x square. It is x square. Okay, here we have x square plus 4 sin x. We'll just check. This is equal to start with 0 always, end with 1. Step size will take 0.1. So therefore, here what we get the corresponding values, and here we can find all the terms are in positive. Just cut it. Cut the table. All these are 0, all are positive. Okay, then after this we'll take again equal to, we just say AC equal to start with the 0. Minus 1, we just take it. Step size 0.1, which is an error. So there is no negative term in this. So we want to find smallest positive. We'll repeat this once again. Just go to EC. We type the equation here. Just press N equal to start with 0, end with minus 1, step size 0.1. There's an error. So means it is clear that f of minus 1, if you consider, we get an error, and f of 1 is also a positive value. You can see in this example, we'll press start with 0, end with 1, step size will take 0.1. So which is, you can see all the terms here are positive. That is, we got this as 0.019169, 0.0169, which is a positive again. Even this is, we consider the positive value. Negative, there is no negative. Therefore, we say that x is equal to 0 itself is a smallest positive root. So likewise, we can easily find the answer. It's 0. If it is not 0, we'll find out the least positive or smallest positive root. Okay, we'll go to the next question, students. Question number 4. We'll calculate the question number 4. Sorry, by mistake. Just number I have changed. Okay, we'll go to the Taylor series method to find y is equal to 0.1. Find, given that dy by dx is equal to e raised to x minus y square, y of 0 is equal to 0. So let us take the function here now. The fifth example we are going to solve. This is fourth one. Okay, this is fourth one. Fourth example. This is third one. Okay, we'll go to the immediately solution of fifth one, where they have given, we're going to use Taylor series method. In this method, students, they have given the initial value problem, e raised to x minus y square, and the condition here they have given y of 0 is equal to, keeping in the mind that what are the initial conditions, we'll substitute in the given function 1 by 1. So first, remember the formula, students, and now we'll start with our derivatives. So please remember, whatever they have given, we are going to consider this as y dash equal to e raised to x minus y square. So when I substitute here 0, y dash of 0, it is e raised to 0 minus 1 square, which is equal to, again it is 0. So x is 1, y is, and you can use the calculator also, students, if you want, but first you have to differentiate this. Now second differentiation, y double dash, this is second differentiation, y double dash is equal to e raised to x, differentiation remains as it is, minus differentiation of y square will remain 2y y dash. Please remember this, students, differentiation of y square, differentiation of y square will be 2y, again inner differentiation will be there, it is y dash. Okay, now we'll substitute again the initial condition 0. So y double dash 0 is equal to e raised to 0 minus 2 1 0, which is equal to 1 minus 0, which is equal to 1. Okay, immediately we'll go to the third derivative, third differentiation. Differentiate again with respect to x, e raised to x remains as it is, minus. Now here you can see 2, we'll use the u into v rule. So y as it is, y double dash plus y dash into y dash, differentiation, students. Therefore this is equal to e raised to x minus 2y y double dash plus minus into minus into plus minus 2y dash square. Okay, we'll substitute the initial conditions. Y triple dash of 0 is equal to e raised to 0 minus, substitute the values in this, students. So it is e raised to 0 2 times, so this y means y is 1, y double dash is 1, y dash is 0. So therefore this is again, please remember, this is 1 minus 2, which is equal to minus 1. Okay, no problem. We'll go to the fourth differentiation, students. Differentiate 4 times, so it will be e raised to x, differentiation is e raised to x minus, now again we'll differentiate this 1 by 1, 2 remains outside as it is, differentiation, or this is again we use u into v rule, this is u, this is v, so u as it is, differentiate v triple dash plus y double dash y dash plus, this is y dash into y dash, please remember it takes as y dash square, so it is again 2 y dash y double dash. Inner differentiation will remain here, friends. So therefore, this is 2 y dash y double dash. Okay, we'll substitute the all the values here, students, in this. So therefore, this is equal to e raised to 0 initially. Y, and substitute the initial values, minus 2, y is 1, y triple dash is minus 1, here you can see it is minus 1, plus y double dash, here we have taken it is 1, this is 1, and y dash is already given. You calculated y dash. What is y dash here, friends? Y dash is 0. Okay, y dash is 0, no problem. Then plus 2 times y dash is again 0, y double dash is 1. So after simplifying, what we get here, friends? Y raised to 4 is 1 plus 3, which is equal to 4. This is 0, this is 0. Minus into minus will become plus 2, and this is e raised to 0 is 1. Please remember, e raised to 0 is 1. So now we'll substitute in the Taylor series expansion one by one. Taylor series expansion, here we have f of x is equal to f of x naught plus x minus x naught, f dash of x naught plus x minus x naught square upon 2 factorial, f double dash of x naught plus x minus x naught cube upon 3 factorial, f triple dash of x naught plus x minus x naught raised to 4 upon 4 factorial, f raised to 4. Okay, I'll substitute this one by one. This is 1 plus 0 into x. So x minus x naught is x only, x naught is 0. So therefore x remains as it is. F dash of x naught is 0. So this is x plus 1 by 2 x square plus 1 by 6. Please remember to substitute the values. 1 by 6 plus into minus will become here minus 1 by 6 x cube plus 1 by 8 x raised to 4. This is the answer. So quickly we have simplified this answer. Now we'll substitute in the Taylor series, that is what we wanted to find. We'll look at the question. Here you can see we have calculated the Taylor series. Now they wanted to find, they have told us to find y of 0.1. Okay, this is the equation we have calculated. Now I'm going to find at 0.1. So let us substitute 0.1 to find y 0.1. We'll take x is equal to 0.1. That implies y of 0.1. Substitute everywhere 0.1. You'll get this value as 1.0018. You can try it in the calculator. Okay. Quickly, we'll go to the next question here, students. The next question says that Laplace transform of t e raised to 2t minus 2 sine 3t divided by t. One by one, we use the Laplace transform. First, we'll use on this t e raised to 2t, and then we'll apply the Laplace transform on this side. So here we have question 6th question. So we'll take the example 6 now. Solution 6. We will calculate now. The Laplace transform of first, please remember, t e raised to at. This is 1 divided by. This is by formula. Please go back to the formula list. You'll get this answer, students. This is the formula. We want to calculate for a is equal to 2. So therefore, Laplace transform of t e raised to 2t, which is equal to 1 divided by s minus 2 dot. This is by formula. Okay. Now we have to calculate. This is first one. I have divided into two parts. This is first part. Part 1. I'll take part 2. In the part 2, I want to calculate Laplace transform of sine 3t divided by t. But as we know the formula. We know that. What is that, students? Laplace transform of sine at divided by t is tan inverse a by s. So you know a now. For a, I will substitute. Therefore, a is equal to 3. Correct now? I will substitute in the formula in this case. So therefore, Laplace transform of 2. Yeah, please remember they have given even here 2. Therefore, let us take this as 2. In the question, they have mentioned it as 2. Look here. It is 2 sine 3t divided by t. So definitely a is equal to 3 we are going to consider. But here it is, the given question, it is 2. So let us take 2 sine 3t divided by t. which is equal to 2 remains as it is. This is tan inverse A is your 3 divided by, yes, this is by directly formula. So therefore, the given question to find Laplace transform of t e raised to 2t minus 2 sine 3t divided by t is equal to, just substitute the values, 1 upon s minus 2 the whole square minus 2 times tan inverse 3 by s. Now sometimes if you simplify this, you can also write this as 1 upon s minus 2 the whole square minus 2 times cot inverse s by 3. So simply modification is there. Instead of this, you just interchange this role of tan inverse, so 2 cot inverse s by 3. So we want s in the denominator, numerator, therefore we have interchanged. That's it. So this is how simplification we have done. So the last question here we have, let's finish it very quickly. Look here, students. So they have given this is inverse Laplace transformation. Let us start with the seventh question. Let's simplify the seventh question here, students, quickly. Solve seventh example. Solve seventh one. Inverse Laplace they have told us to calculate. Let us take the function f of s is equal to log of s plus 1 divided by s minus 1. They are told you to calculate the inverse Laplace transform. Let us simplify this. So as you know, log of a divided by b, log of a divided by b is always equal to log of a minus log of b. So therefore, we use this logarithmic property. We get this as log of s plus 1 minus log of s minus 1. And now we differentiate this with respect to s. We get df upon ds, okay, which is equal to 1 divided by s plus 1 minus 1 divided by s minus 1. Now we find one by one the Laplace transform on both the sides. As we know the formula, that inverse Laplace of 1 divided by s minus a is equal to e raised to a3, correct? So therefore, if you take Laplace inverse of 1 divided by s plus a, it will become e raised to minus a t. Is it clear? So therefore, so here there is no calculator to use, so we'll substitute here. Now Laplace transform of inverse Laplace transform of df upon ds will be equal to Laplace transform of inverse Laplace transform of s plus 1 minus 1 upon s minus 1. We'll apply Laplace on both the sides. Therefore, this is equal to, we get this as students, a, here a is 1. Okay, here also a is 1. Please remember, here it is minus 1 and here it will be 1 only. So it is e raised to minus t minus e raised to t. This is what we get the Laplace transform. Now, we'll take out this inverse Laplace, which is your f of t. Focus. So therefore, we take this as t, f of t, which is equal to e raised to minus t minus e raised to t. In this case, when we take L inverse, it will be in the form of negative, because the function here given df upon ds is, we are going to consider this as minus t f of t. Therefore, f of t is equal to minus, or take it on this side, so it is e raised to t minus e raised to minus t divided by t. This is the answer. This is how we have to calculate the values. Thank you so much.